The next book is a book on representation theory. Charles Curtis, Pioneers of Representation Theory, Frobenius, Burnside, Shore, and Brouwer. And this is actually a book on the history of representation theory, but it actually does representation theory historically motivated as well. So it is actually also a textbook on representation theory, taking the history into account. So we start in chapter 1 with some 19th century algebra and number theory, ruler and compass constructions, equations, cyclotomic field, quadratic reciprocity, Dirichlet L series, characters, and so on. Then we get to Frobenius and the invention of character theory, Burnside, representation and structure of finite groups, Shore, a new beginning, and polynomial representations of G, L, and C. Then Richard Brouwer and Emmy Noether, and modular representation theory. So this book starts off in the 19th century, and basically with Gauss and constructibility and everything. Basically everything that was done at that point, and then moves on and establishes representation theory, establishes group theory and everything to do with it, and actually discusses why it was necessary historically to invent this kind of thing. And then it ends off with Noether and her work on representation theory and on algebra. So Crimson, if you are watching this, if you are still watching my videos, I think you would like this book. I would highly recommend a book like this for you. I'm not sure you're too interested in history, but I do think it's particularly nice, even though I guess it doesn't really involve any combinatorics. But yeah, highly recommend it to basically everybody. Then we have the following book, Statistical Thermodynamics and Information Theory Approach. Mirror might be interested in something like this. So we start off with Introduction to Probability Theory, Introduction to Information Theory, Statistical Systems and Microcanonical Ensemble, Equilibrium and Temperature, Thermodynamics, the Laws and the Mathematics, Applications of Thermodynamics, the Canonical Distribution, Application of the Canonical Distribution, then Phase Transitions and Chemical Equilibrium, finally Quantum Statistics, Applications to Quantum Statistics, and Black Hole Thermodynamics. So this is basically a book on thermodynamics together with a book on entropy, and on basically thermodynamics and the information theory approach, which I think is the vastly superior approach to see anything related to thermodynamics. It would be information theory discovered by Shannon in quite a different context. But yeah, I think it's absolutely powerful. It's absolutely the best approach to seeing this. And of every book that is out there, this is maybe the only introductory book that really does it like this. So yeah, very excited to read this one. I haven't read it yet. I just received it. So I'm very excited for this one. And yeah, definitely something I would be interested in doing with people down the line. Next we have the following book, well known of course, it's Cox Little O'Shea, Ideals, Varieties and Algorithms, Introduction to Computational Algebraic Geometry and Commutative Algebra, and this is the 5th edition. So I usually recommend people the 4th edition, because the 5th edition didn't exist yet, and I just got this book yesterday, or the day before, and it's basically just out. Even though I guess there's, if you really look at the table of content, there isn't really too much new in it. There's toric varieties, there's monomial curves and numerical semigroups, there's numerical algebraic geometry, there's some Galois group theory, there's permanence. Yeah, so that's basically it, and I guess typos are being corrected. So I definitely still recommend this book to everybody. I think it's an excellent book. Very excited to go through the 5th edition, and if you're interested in algebraic geometry, I think this is the book for you. This is the book that you really want to read first. Such a good book, such an excellent, beautifully written book. Next we have Physics from Symmetry by Jacob Swichtenberg. This is the 2nd edition. Now, Jacob Swichtenberg was actually an undergrad when he wrote this book. So he wrote it in a way that was understandable for him, and many people actually found it useful. So it starts with special relativity. It then goes to Lie group theory, the framework, then it goes to measuring nature, free theory, interaction theory, quantum mechanics applications, quantum field theory, classical mechanics, electrodynamics, gravity, and then some closing words, and then some appendices. So definitely a good book to read on symmetries and on how they're essential basically in modern physics, and also in modern math, by the way. I guess the problem with this book is that it doesn't really have any exercises. Like there's no exercise at all in here, which is, I guess, a shame. Still, it's an extremely fun book to read. Good book to go through. Next we have here Differential Equations, a Dynamical Systems Approach to Theory and Practice by Viana and Espinar. So it's a book on differential equations and on dynamical systems and everything to do with it. Let me see if I can find the table of contents. Here it is. So basically we start with local solutions, the usual theorems, maximal solutions, numerical integration, autonomous equations, autonomous linear equations, non-autonomous linear equations, Lyapunov stability with the Lyapunov exponents, Grossman-Hartmann theorem, stable manifold theorem. We get vector fields on surfaces, including the Poincaré-Bendixson theorem, Poincaré-Hopf theorem. So yeah, it's basically an entire book on ordinary differential equations and their underlying, very deep underlying theory. Excellent book, of course. Next we have here Mathematical Foundations for Electromagnetic Theory by Donald Dudley. So we start with linear analysis, Green's function methods. Then we get spectral representation methods, electromagnetic forces, and electromagnetic boundary value problems. So it's all about the math of solving electromagnetism problems, basically. Sturm-Liouville theory and everything related to that is basically every kind of math related to this kind of thing. Next we have here Fundamentals of Electromagnetism by Davalos Zanet, Vacuum Electrodynamics, Media and Relativity. Again, electrodynamics book. So we start with relativistic kinematics. So we start immediately with relativity theory, which is a good thing. Relativistic dynamics, electrostatics, the Poisson-Laplace equation, magnetic fields, Maxwell's equations, dynamic fields and radiation, covariant formulation of electromagnetism, fields in material media, linear material media, waves in material media, and electromagnetic theory of superconductivity. So yeah, a very high level electromagnetism book, very difficult. It's definitely not something that should be your first book on a topic, but yeah, it does treat things the right way, it seems. Next comes a book I like very much. So it's Kunststadter Das, a first course on symmetry, special relativity, and quantum mechanics, the foundations of physics. Definitely up for doing this one at some point. So we start with symmetry and physics, formal aspects of symmetry, symmetries and linear transformations, special relativity basics, special relativity 2 in depth. Next we have general relativity, introduction to the quantum, the wave function, the Schrödinger equation, the hydrogen atom, nuclear physics, mysteries of the quantum world, and yeah, then some appendices. So it basically treats physics from symmetry, which is really the way to see physics, especially nowadays. So yeah, yeah, extremely fun book, extremely good. Next book we have here a book by Robert S. Elliott, Electromagnetics, History, Theory, and Applications. So we see here that is basically a book doing history of electromagnetism and teaching electromagnetism historically. So we start with the phenomenon of light, the special theory of relativity, electrostatics in free space, magnetostatics in free space, electromagnetics in free space, dielectric materials, conductive materials, and then a lot of appendices and mathematical supplements. So yeah, it's basically trying to do electromagnetism from the historical approach, which I personally appreciate very much, and which I personally like very much. The book is quite undetailed in the math, like it skips math steps, and therefore it's not an easy book at all. Next we have this very short book, The Conceptual Foundations of the Statistical Approach in Mechanics by Paul Ehrenfest and Tatjana Ehrenfest. The big names, of course, of statistical mechanics. So we start here with the older formulation of statistico-mechanical investigations, kinetostatistics of the molecule. Then we have the modern formulation of the same thing. Gibbs' elementary principles in statistical mechanics. Yeah, and it's basically a very good treatise by a master in the field. So definitely something I wanted to have, basically. And then finally for today, we have here Statistical Mechanics for Beginners by Lucien Gilles Benguigui, I think. So yeah, another statistical mechanics book. And this book starts with the closed system of the microcanonical ensemble, the system in thermal contact with a reservoir, the canonical ensemble, and the grand canonical. Next, quantum statistics, density of states, some problems, gas of photons, the black body radiation, atomic vibration in solids, phonons, the boson gas at low temperature, the Bose-Einstein condensation, the gas of fermions, electrons in metals and semiconductors, neutron stars, and finally a history of statistical mechanics. So yeah, just a statistical mechanics book, a pretty short one. Yeah, can't really comment on it much.